Let's try the MacBook microphone. Okay, so now it's working. I'm not sure if I recorded myself, so I'm going to repeat what I said. So today's my first time learning about reservoir sampling for my random pick index problem that I'm studying for Meta. And it's super interesting. So I want to take this opportunity to explain it to myself because it took me a long time to get it. So let's get started. I'm going to share my screen, the whole desktop. Yeah, the meta grind continues. What, 4 more days until my actual phone interview. So let me go to my solution here and let me reset everything. Is that a whiteboard? Oh, I can annotate. That's awesome. I didn't know that. Anyways, uh, go away. All right, so let's see. Random pick index. Let me reset this. So we are given an integer array nums, right, with possible duplicates. So nums will contain duplicates. We need to randomly output the index of a given target number. And we can assume that the given target number will exist in the array. So, we need to implement the solution class, which takes in a nums object for the constructor. And for the pick, it will take in a target, and we need to return a index I randomly in nums, where this nums at the current index is equals to the target. And if there are multiple valid i's, then each index should have a equal probability of being returned. All right, so let's go through an example to make it make sense, basically. So if we are given 1, 2, 3, 3, and we are calling to pick three, then as you can see here, three is at index two, three, and four. So whenever we call pick and the target is three, then two, three, four should have an equal probability of being returned. So the probability is 1/3. And then when we pick one here, we see one is only occurs once in this input array. So the chance of the index zero being returned would be 100%. Yeah, so this is just basically explaining it. So how reservoir sampling works is it's like this. So let's take this example, right? And let me annotate here as a comment block. So say we have this and we call pick and the target is three. So let me do a indexes here too. So index here would be 0, 1, 2, 3, and then 4, right? So pick three. What are the possibilities of indexes would be 2, 3, and 4, right? Because the threes are here. So reservoir sampling it doesn't require any extra space. So the time complexity is O of n, but the space complexity is only O of 1. And this is a trade-off to using the hash map solution, right? So going off a little bit here to discuss the other solution. So let's do a hash map solution. So if we're given this example, then we just group them by the number and the indexes. So one would be one, and then two would just be one again. Sorry, the index would be zero. And then finally three, the indexes would be two, three, and four, right? Okay. So in this case, in this hash map solution, if we call pick three, then we just get the size of this of three of the list of indexes of three and basically generate a number randomly, generate random int from 0 to size -1. So in this case, the size is 3. So you generate 0 to 2 size is equals to 3, right? So the size here is 3. So generate 0 to 2 and then return um the index at the generated num. So we would just return, let's call this like index list, get the generated number like that. So this one, the time complexity is O of n for the solution. So we need to populate our hash map for constructor, but O of 1 for pick. However, the space complexity is O of n because using hash map, right? So this is good if we know that nums will never change. Like we're not inserting another 3 or anything like that. However, the reservoir sampling solution is very interesting in that how it works is we need to traverse through this array. Okay, so say we have like I here is equals to 0 and we're calling pick 3, right? So at the beginning, let's have a occurrences. In this case, it would be of 3, right? So it's initially 0, and then the picked index would be initially -1 because we haven't found 2, 3, or 4 yet as our index is currently at 0. So we keep going, and then finally we are here, right? So when index I is equals to 2, we encounter our first 3. So then now the occurrences of 3 is now 1. So what we do at this point is we generate, so for every 3 encountered, generate a number from 0 to occurrences -1. And then if this number, this generated number is basically equals to 0, then pick this current index I. So how it works is basically I is equals to 2, right? And the number of occurrences gets increased from 0 to 1, and the picked index is -1. So what are the generated possibilities here? So generated possibilities would be when I is equals to 2. So it's our first time getting 3, right? So we generate from 0 to 1 minus 1. So our only possibility is 0. So what is the possibility of picking 3 at index 2 here? So possibility of picking 3 at index 2 is equal to 100%, right? So now picked index becomes 2, okay? So we move on. The next index here, I is equals to 3. We see that our answer is also 3, which is what we're looking for. So let me just copy this again. So when I is equals to 3, it's our second time getting 3. So our occurrences now gets increased to 2. So now we generate from 2 to 1. So the possible values are 0 or 1. So the possibility of picking 3 at index 3 is now 50%, right? Because we could generate a 0 or a 1. And so if we generate a 1, then we don't pick 3, and we keep the picked index to be 2. However, if we generate a 0 here, then now our picked index won't become 3. So bear with me. When we move on to I is equals to 4 finally, right? So we see that it's also equals to 3. So let me do when I is equals to 4, it's our third time getting 3. So the generate possibilities, so now our occurrences would become 3, right? So then here, 3 minus 1 is 2. So we can generate from 0, 1, and 2. So the possibility of picking index uh picking 3 at index 4 is 1 over 3 because we can pick 0, 1, or 2. We can generate them. So then, which is basically, if you calculate the possibilities here of picking 2, 3, or 4 here, each will have a possibility of 1 over 3. So at this point, each indexes 2, 3, and 4 have had an equal probability of 1 over 3 as being picked. Why? So let's say here, right? If we are at index is 4, right? And our picked index remains at 2, then what are the possibilities? So the possibilities when here is 100%, which is 1, right? And then when I is 3 and we still pick this, the possibility is 1 over 2, right? Of not picking index 3 and then remaining at 2. And then when we're here, the possibilities of picking index 4 is 1 over 3. So the possibility of the index remaining at 2 is now what? 2 over 3. So if we multiply this, it's going to be 1 over 2 times 2 over 3, which becomes 2 over 6, which simplifies to 1 over 3. So picked index for 2 has a 1 over 3 probability. And similarly here, right? If picked index remains at index 3, so if it's here, what are the possibility? So the first time when I equals 3, then the probability is 1 over 2, right? And then when I is equals to 4, the possibility of picking index, 4 is 1 over 3. So the possibility of 3 to remain as is 2 over 3. And this also, when multiplied, is equals to 2 over 6, which simplifies to 1 over 3. And then the picked index is 4, right? Is equal to 4 when we're finally here is 1 over third because of the calculation here. The generated number has a 1 over 3 chance of being 0, right? So it's also 1 over 3 and voila. So that's why random pick index, even though it's O of n, it makes sure it's very interesting in that it makes sure the probability of selecting these indexes is equal to each other, which is crazy to me. Um, what are some, if I watch this and I still don't understand, I can look at the solution here and it's like the simple reservoir sampling solution. And I just read the comments. So yeah, they explain it too, right? When the input is here, the probability of selection is 1 times 1 over 2 times 2 over 3, which is 1 over 3. And then 1 over 2 times 1 over 3. And I guess why is the probability of remaining at 3 here is because we can either, this index, then we can either pick index 4 or we can remain at the previous picked index, which is either 3 or 2. So yeah, if you watch this again and if you get confused, just gotta go through this code right here and do it out on the whiteboard, kind of like what I've been doing here. And then you will get a big ass whiteboard here. As you can see, it's like all this stuff. Then you are going to get the correct answer. It's crazy. Um, so now that's the logic of it. I'm gonna go ahead and just implement this solution. So it would so like I said, the time for pick index space O of 1. And when would we use this? When we don't know how many, when we can't use any other data structure, when the requirement for the space complexity is O of 1. So here, let me make some global variables. So let me make nums available globally. So int nums, and then let's get int n is equal to, this would be the length of nums. And I believe that is all that we need. So first we set this nums is equals to nums and n is equals to nums length. Okay, so for the target here, we first need to do a number of occurrences. It's equals to 0 because we haven't found any target yet. And then we need to do a picked index. The index we are picking is equal to -1. And then we need a random generator too. So let's do a random rand and initialize it here. Rand is a new random, just like that. All right, so when we do a pick function call, we need to iterate to find all occurrences of target, right? So just a typical for loop in I equals to 0, I is less than n, I plus plus, okay? What we do here is we check for the occurrence. So if nums at index I is equal to the target, then we do the reservoir sampling. Then we first increment the occurrences uh, by 1, and then now we do the sampling. So if it's our first time, then we do a int generated num is equal to math or random next int with the occurrences as the upper bound, right? So this generate 0 to occurrences -1 inclusive, right? So we check if the generated num is equals to 0, then we pick this current index, and picked index is equal to I. And at the end, we just basically need to return the picked index. So this might be confusing, but let me do this walkthrough again. I know it's long, but I'm gonna copy this and just do my walkthrough. So we have this for loop here. Okay, like that. Okay, so when we have our pointer here, right? When we encounter our first three, then what's our occurrence? Our occurrences is 0 initially, right? And picked index, so picked index is equal to -1 initially based on here, right? So when we encounter our first three, when I is 2, then we go into this. We increment occurrences, so this becomes 1. So now we get generated num. So gen num is we're generating from 1. So from 0 to 1 minus 1, which becomes from 0 to 0. So there's 100% chance that this index of 2 will be picked. So generated num can only be 0 at this point, right? Because our range is from 0 to 0. So now picked index is definitely 2, okay? So we increment to here, right? So we see that nums at I is equals to 3 again. So occurrences will get incremented to be 2. And so now we generate num from 0 to 2 minus 1. So from 0 to 1. So the possibilities are 0 and 1, right? So which is 50% of picking 3 as index. Say we generate nums to be 1, so picked index remains at 2, right? So we move on to 3. So now occurrences is now 3, and picked index is still 2. However, the generated num can be from 0 to 2. So 3 minus 1 is 2. So possibilities of 0, 1, and 2. So now we have a 1 over 3, or like 33% chance of picking 4 as an index. So, which means 2/3 chance of basically 2 remaining as the picked index. So that just walks through like this case right here, right? The first time, 100% chance, 50% chance, and then 2/3 percent chance, which is 1/3. So yeah, that's basically a quick walkthrough. Hopefully, when you watch this in the future, you will understand reservoir sampling. It's very interesting. I've spent like 2 hours on this now. Um, how many questions are remaining here? 58, but if I refresh, it should be like 59, hopefully, man. I just did the reservoir sampling. Did it not record my solution? Picked random pick index. It didn't record? What? Okay, I'm just gonna go here and I'm just gonna, oh, because I haven't pressed submit. So I'm gonna submit. Of course, I miss a semicolon. I should have ran it first before I submit. So now I'm gonna submit. Cool. It works. It's very slow, but it's the solution that Meta wants because the hash map solution is way too simple. So yeah, 59 now. Let's move on to the next problem. There's like three very interesting problems in the top 10 that I need to go through. It is nested list weight sum, which requires a prefix sum, and dot product of two sparse vectors that I need to go through because these are very tricky and they're very open-ended, which can prompt discussions to see my problem solving. So yeah, man, let's keep going and let's get to at least 100 today. I think it's doable for 100 today.